Well, hello everyone, Sky Protocol community. This is Gauthier, and I'm with my partner in crime, Fare. Hi, Fare.
Hello.
Alrighty, so today is a big day, code update. We have quite a lot to show because we've been super busy, and from time to time we say, oh, we're going to do that video tomorrow, and sometime we have actually more to do, so we prioritize other things. But today is a video day, so Fare, please enlighten us, show us that code update.
Hello. So we have updates on two main fronts. The two main fronts are the contract and the testing of the contract itself. And the other front was the data structure we were implementing of a try that Yaroslav and I have been working on. So maybe let's start showing you a bit of what Manuel has been doing. Where is that code? Let me show my screen. Present now. Let's present Emacs. Where's Emacs? Da, 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 da. Window. Window, which window? There should be a window that says Emacs. Buffer list is called. Share. So, no, this is, okay. So you may remember that Manuel had a file called Sky Bridge Contract, which is the main bridge between Sky and Cardano, and it's written using Plutus. And I think we looked at it last time. It hasn't changed much. It has just improved a bit. And most of the work on the contract side has been with the testing, with a testing layer written in JavaScript, which is so you look at Sky protocol, contracts, off-chain, HTTP API, and therefore another function update bridge, which will test the updating of the bridge. So there are plenty of other files of infrastructure files for JavaScript, and that's where we can automatically test and interact with the bridge. In the future, we may want to move away from JavaScript for many reasons, including security, because frankly, I do not trust at all the JavaScript ecosystem from a security point of view. Although there are also pros. It gets attacked faster. It also gets defended faster. So depending on the kind of attacks that you expect, it may or may not make sense. But I believe that the trade-off is slightly wrong for crypto projects, because we're not allowed in crypto to make one mistake or all the money goes. So I prefer personally to deal with a platform that has fewer risks, that may evolve slower but has fewer intrinsic risks.
So is it?
But for testing, that's perfectly fine. For this testing code and testing infrastructure, fast development of testing code, this is exactly what we want. We want to move as fast as possible, and by using JavaScript, you can reuse a lot of existing libraries, like plenty of things, Mesh SDK and other things like that.
So it's okay for a small mainnet or a testnet, but in the future, when we have like many users of Sky Protocol, we should really focus
Yeah.
on other technos.
Also, this is available. This code written in JavaScript right now is code using for testing. It's not code that will be used by us in production. It's code that is purely test infrastructure. So our code will be in Haskell mainly, and none of this JavaScript code will be in our production code. It's all for the testing infrastructure, and maybe for the deployment infrastructure, like code that is not used by, let's say, end users. So that's fine. I think for this kind of usage, JavaScript is a fine thing. And so we have all the things where we create basically a new bridge contract, and that's how we create an NFT for the bridge contract, and we create the state for the bridge contract, and we send it to the Skybridge, and we create everything. So that's how the update works. Meanwhile, Yaroslav and I have been working on try data structures. The latest variant that I'm working on is called mytry.hs. So one advantage of writing it in Haskell this way is that it's the exact same code that will be run on Bluetooth and on the server and on whatever. If someone wanted to write a full client in Haskell, they could also. But because it's the very same code, there is no leeway for discrepancy between the two, and that's important. There are other ways of doing it, of course, but by doing it that way, it's like this part is correct by construction. So, and then I use a lot of something called a zipper monad. So if you're interested in, not monad, zippers, sorry. If you're interested in zippers, I will give a full explanation of how this thing works at LambdaConf in May in Colorado. I invite you to attend if you're technical LambdaConf. It will be a great conference. And I will be presenting two things at LambdaConf, and one of them is this: how do we use zippers to get Merkle proofs for free, essentially. So with these zippers, we also get more efficient accesses to our tries. We can build tries, and we can build them incrementally. The zipper infrastructure is the thing that allows you to build basically incrementally and to move inside your try, to have not just a try view from the top, and every time you access, you go down the try, but you can have a try with a focus and be able to zip back from the focus point to the top of the try. So that's
technical explanation for the non-tech guys. Can you explain what is a try, please?
Oh, sorry, a try. The try is the basic data structure used by Ethereum and many other blockchains. I think our try is technically slightly different from those of Ethereum, but conceptually it's the same thing. A try is, you can think of it as a binary tree that is as full as possible, a balanced binary tree that is as full as possible. And so the fact that it's balanced means that the accesses will be relatively fast as can be in this context, and binary tree. So let's look at the definition of a try node, for instance. Try node. A try node is either an empty try, that's an empty node, or it's a leaf at the bottom of the try, or it's a branch we can have left and right, or sometimes we can even, for other optimization, skip a few nodes because we know that the try is empty except for one subtry. And so, but all the leaves will be at the same height, and so we can maintain the height of your try. So which means that if you have a height, say a height 20, you can have between 500,000 and 1 million entries with a try of height 20, and with a try of height 0, you have exactly one element. A try of size 1, you have exactly 2 elements. A try of size 2, you have 3 or 4 elements. A try of size 3, you have 5 to 8 elements. A try of size 4, you have 9 to 16 elements, etc., etc. And so it's an efficient data structure. It's the basis of Ethereum. It's also the basis for our for Sky protocol. And basically everything gets added to a try when you use Sky. And the try is basically this big table of all the data, and because it's balanced, you can access the data in logarithmic time. So if you try, say you have millions of data, then your try is of depth 20, of height 20, and then in 20 accesses you can access anything. So this is beautiful, and it's balanced. A try has also, more precisely, a big Indian Patricia try has other lots of other nice properties that make it perfectly suited for use in a blockchain. And one of them is, for instance, it's deterministic. So for a given set of data, there is only one, and exactly one trie that has this exact set of data. So you can compare. You just need to compare the thing, the top, to see if it's the same. And we use Merkleized tries, which means that for every node, we are going to remember its hash digest. So we use for something called a reference digest wrap, or maybe I should call it digest ref instead. And it has a wrapped value and a wrapped digest. And basically, you remember always the digest of the thing that's in it. The digest is you compute a hash function of the data. So at every level, you remember the digest, and that makes it very efficient. And also that makes it very efficient to compare the data of two trees. So basically, if you have 2 or 3 people working something in parallel, and they can work in parallel and yet arrive to exactly the same result because they use a trie, and they can just compare. Oh, we reached the same result. The fact that they reached the same result, they can verify that just by comparing the digest at the top. So some operations we like become very efficient with Patricia Merkle trie. So that's what we're using. So we are using these many tricks that I was using the Scheme version that I've been porting in the Haskell version. So Haskell makes some things easier, I suppose, like testing that the types are correct and that you can't make type errors. That's nice. You can also derive things, like there is a lot of metaprogramming infrastructure available in its type system and its type classes, etc. Some things are harder than in Scheme. You have to sometimes fight this type system. The main thing you have to fight is because the way that Haskell does side effects, you have monads everywhere. So I have monad E everywhere for effects. That's a pain. But refocus. All the magic of tries is in this function called refocus, and it's beautiful. It basically moves the focus of your zipper along your trie from one point to the other, and that's what does most of the magic of the trie, and everything else is simple. So, for instance, if you want to see, we can use zippers for doing many things. Zipper update is the one-liner. Once you have the focus, the refocus, modifying something is just focusing, changing the focus to where you want something to happen, and then updating the leaves. What else can we do there? We can do the non-zipper things are also trivial. So update something, person it into a zipper, do the update to the zipper, and then get out of the zipper. And it's all, a lot of things are beautifully simple. Like a lot of things are one-liner or two-liners because of this infrastructure we use. So we put all the price, like this function that is like refocus. Where is it defined? This function that is from line 172 to line 278. So it's a 100-line function. So this function is a bit much. It's commented, but it's a bit much. But all the complexity of the code is all in this function. And so you have only one single 100-line function that has all the complexity of the data structure, and everything else is trivial. So I like that, the fact that now if you want to verify that the code does what you want and that there is no bug or whatever, you have this one and only function to study, and everything else everything is straightforward. So no, I think that was what I want to say. So the report construction. The key takeaway is that we're almost at okay. Let's step back. We are hoping to deliver milestone 4 of our Catalyst grant at the end of the month still. So what remains to be done mainly is integrate this try code with manual contracts, and then add a little bit of glue or API to it, which will be a first version of the API we want to deliver to our users. But I don't think it will be an official API by the end of the month. We're slightly late for that because we took some delay during December. But I think like early in February, we should have an official API that we can show our users. And of course, this API will evolve, and we evolve with the feedback of our users, but we will be able to tell, hey, this is how we think you should be using our service. And this will be available in February. And this month, we're focusing on our deliverable for Catalyst. So integrate this try data structure with manuals code, and then we'll be good. And add a few tests and integration tests, and we'll be good.
Wonderful. All righty. And so the key takeaway for the bridge for the global fate of Sky Protocol, not only the Catalyst milestone, but to sum it up for our listeners, for the like in very simple words for the guys who are less interested in technicalities and more about the concrete use. What does the bridge do, to sum it up?
Okay, so the bridge reminder. Sky Protocol ingests a lot of data from the users. We put that data in a data structure called this try data structure, partial try, same as in, or close variant of what is used in Ethereum. And once in this try data structure, we publish the head of this try data structure to Cardano using the Sky Bridge. And then any contract in Cardano can verify that some data was included in our big data structure. So that's the whole point. So you can use our publish lots of data at scale onto Sky Protocol, and then use a Cardano smart contract to verify that the data is indeed there.
Wonderful. All right, and you want to show us also what you do with Yaroslav?
Yaroslav is working on another. He helped me write this thing, and he wrote a previous version of mainly the same data structure and make it work. So this is the Yaroslav version that has Merkleization. It's slightly more complex. It's slightly more ad hoc, but it works. And so this is a part that Merkleizes things. So in 100 lines, all included has a Merkleization, and the version here is a basic version, also in relatively few lines. Heaping does less, it's less efficient, it's less general, whatever, but it works. And it was the basis for my version that I worked on. So it also does use a lot of nice tricks. And so my version uses the tricks that Yaroslav showed me, plus the tricks that I had in Scheme, merge them together, find the Haskell type system, and now have something that's beautiful. The file is this file is only 500 lines, a bit less. It would be probably a bit more once I add a few more functions, but it's beautiful, it's simple, and the complexity is really mastered and kept very small. So yeah, that's what I can say. Technically very nice, but also it would be very robust. Why do I care about nice, etc.? Because once you have smart contracts, you can't afford code that is sloppy or that has an error. And for code that is so fundamental, you really want code that is rock solid. And that's why we picked Haskell and other things, because we really want rock-solid code. So yeah, so that's why that matters. Like code that deals directly with the contract and the guts of the contract has to be written in a style that is rock-solid. It is also code that is used a lot for our server. That's why it also has to be efficient. And so it's rock-solid and efficient. I think this code will do both.
Wonderful. All right. And so to update our users, because that was quite a lot of work, what are the next steps for us until the
So next step,
and testnet?
add more tests, integrate that with manuals code, add more tests, publish the catalyst at the end of the month, then early February, publish this data, publish an API and start the testnet. So by the end of February, we'll have a testnet. It will be a centralized testnet, but it will be a testnet. It will work. It will follow the API. You can start using the API. The implementation will change. We'll add lots of features. We'll make it more robust, more decentralized, etc. But the API should stay mainly the same, even as we add features. So as we add features, we need to update the contract, update the data structures, update a lot of things under the hood. But as far as the users are concerned, the usage should be mostly the same. And that's what matters.
All righty, so that's great. We are slightly late in terms of testnet compared to what we hoped, because we were thinking maybe first month of 2025. Then again, considering we also developed many other pieces of tech that will be needed later and that were not expected at the beginning, that's a good trade-off.
Right. I mean, we are late compared to provisions, but not so late that it's worrisome yet. The thing, Hofstadter's law, like programmers are often too optimistic as to how long it takes. So we were optimistic that we would be done by the end of December, but yeah, they do. I think we're still doing okay, good.
Wonderful. Thank you, Faré. That's great. Any last thing you want to tell the users regarding either nodes or other works we have regarding Sky Protocol, like the tokenless version or something?
So right now we're preparing a set of Docker images that you will be able to run Sky Protocol inside. Once again, centralized version of Sky Protocol, and so that's how we plan to distribute the code in the beginning as Docker images. Of course, we can rebuild everything using the same tools that we use, but you won't have to rebuild everything because it will be packaged in the Docker image.
Wonderful. Alrighty, thank you, Faré. Everyone, this was the code update from Sky Protocol, end of January 2025. We have a lot to do. Also, for the things we're planning soon, on top of the technical milestones, so Faré and I are going to work on the node distribution model to have a real set of numbers to tell you exactly how many nodes we need, the kind of hardware you need, but there shouldn't be any surprise in this case. It should be really close to what you can do with a Cardano node, so not a huge PC, just a very standard PC. And we are going to work on the L3 version of Sky Protocol, the tokenless version for other chains, but Sky Protocol stays on Cardano, so out of loyalty to the community and because we have that fondness for Cardano anyway. So these are the next steps. Stay tuned, everyone. Thank you so much, Faré.
Thank you. Thank you for letting me show this code.
Cheers.